For this problem, we're trying to find tangent of 75 degrees, and they tell us to use the sum and difference formula, sum or difference formula, or anyway, so I'm going to use the sum formula, so tangent of 30 degrees plus tangent of 45 degrees. So if you recall that tangent of u plus v, I probably should just write that normal. I was thinking of writing it as a fraction, but that's for the second part. Tangent of u plus v is tangent of u plus tangent of v over 1 minus tangent u, tangent v. That's a v. Okay, so we're looking at tangent of 30 degrees plus 45 degrees to be tangent of 30 degrees plus tangent of 45 degrees over 1 minus tangent of 30 degrees, tangent of 45 degrees. So that's going to be, let's see, tangent of 30 is square root of 3 over 3 plus tangent of 45 is 1 over 1 minus square root of 3 over 3 times 1. So I have the square root of 3. Well, I think just to make this easier, I'm just going to multiply it by 3 over 3, clear out the fractions. And I have the square root of 3 plus 1 over 1 minus the square root of 3. So I'm going to multiply by the conjugate of the denominator. So that would be 1 plus the square root of 3 over 1 plus the square root of 3. And that will give me, let's see, on the numerator, it's going to be the square root of 3 plus 3 plus 1 plus the square root of 3. So 3, yeah, it looks right there, over 1 minus 3. So we end up with 4 plus 2 root 3 over negative 2. Negative 2, we're going to divide that out, negative 2 minus the square root of 3 is what I come up with. Okay, hope that helps. Oh, that's the first one. I was also going to do 77 from this section. And 77 says, let me get to the page of the book. It says, express each of the following as an algebraic function of x. And I have cosine of arctangent of 2x minus arcsine of x. So I find this helpful if I just associate each of these arctangent, arcsines with angles. So I might call this first one, alpha, and the second one beta, such that arctangent of 2x equals alpha, and that would be then that tangent of alpha must be 2x. And arcsine of x equals beta, so that means that sine of beta equals x. Okay, so in doing that part, it might also be helpful. The one thing I see that we could clarify a little bit, I'm going to go ahead and draw the triangles, but we are going to end up with our cosine of a difference with sine of arcsine of x at one point, so that's just an x, so we don't have to do too much there. But in doing this, it's just helpful to draw these little right triangles. And this is a tangent. So we're talking about if this is my alpha angle, I'm looking at tangent being opposite over adjacent. So 2x is the opposite, 1 is the adjacent, 2x over 1. So my hypotenuse, I'll call that c. C squared equals 1 squared plus 2x squared. So c squared equals 1 plus 4x squared. So c equals the square root of 1 plus 4x squared. Okay. And then for the other one, we have, call this beta. And sine of beta is opposite over hypotenuse, so I'll call opposite x, call hypotenuse 1. Think of it as x over 1. So this is my side a squared plus x squared is 1 squared. A squared equals 1 minus x squared. A equals the square root of 1 minus x squared. So we can put all this together and go with that. We have cosine of alpha minus beta is going to be a cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And we already know what sine of beta is because that's what we started with. That was kind of a given. And I'm just going to make a note to that this sine of beta is this x. Okay, so what do we have? Cosine of alpha is going to be adjacent over hypotenuse. So that's going to be 1 over the square root of 1 plus 4x squared times cosine of beta is adjacent over hypotenuse. So the square root of 1 minus x squared over 1. Then, oh, this is a minus, so this should be a plus here. I know everyone's probably screaming at their screens, it's a plus, it's a plus. Sine of alpha is 2x over the square root of 1 plus 4x squared. And sine of beta is just going to be that x over 1 if you need to see that. So we end up with the square root of 1 minus x squared over the square root of 1 plus 4x squared plus 2x squared over the square root of 1 plus 4x squared. So we have the square root of 1 minus x squared plus 2x squared over 1 square root of 1 plus 4x squared. And that's probably as far as I'd go. I'm betting that's the answer in the back of the book because when we get to this point, we don't want to do too much with these radicals. So hope that helps.